So looking at 7.R.3, this is the discussion of rational exponents. So rational meaning a fraction. So if I have a base raised to an exponent that is a fraction, so we're just going to be generic for a second. A base of x raised to the power of m divided by n. What does that mean? So the numerator of the fractional or rational exponent means the same exact thing as the normal exponent means. This is the power that the base is being raised to. So the top of the fraction is still the power just like we think of it. The numerator is the root. So if the the denominator is the root, the bottom of the fraction is the root. So if the bottom of the fraction is a 2, that's telling you want to take the square root of the base. If it's a 3, we're taking the cube root. A 4, the fourth root, so on and so forth. When we're using the rational exponents to simplify a value, the order that we perform these two operations does not matter. So I could raise it to the power and then take the root, or I could take the root and raise it to the power, and we would end up with the same value. So that being said, rewriting the rational exponent in what we call radical form, so actually showing the little square root or the cube root, so what that actually looks like. So x to the power of m over n means that we're taking the nth root, so whatever n may be, but I have the root, the little n on the outside. When it's a square root, we don't put the little 2 on the outside. It's just understood that we're taking the square root when there's no number. But if I'm taking any other root, a cubed root, I'd have a little 3 out here. A fourth root, I'd have a little 4 out there. So the n in the denominator of the power tells me that I am taking the nth root. The m in the numerator is telling me that I'm raising that base to the mth power. So I have the nth root of x to the power of m. And like I said, the order that these operations occur in doesn't matter. So we could also write this as still I'm taking the nth root. So I have the nth root of x. And then I could raise that to the power of m. All right, so the order here is different, but the value should still end up to be the same. All right, so these two forms right here are what we call radical form. And now that we have these definitions, we can convert back and forth between radical form and writing the expression with a rational exponent. So let's do an example of that real quick. So let's say that I have this right here. I have the fourth root of x raised to the third power. And so this is in radical form, and I want to write it back in exponential form with a rational exponent. So remember that the rational exponent, it's a fraction. The top tells me what power the value is being raised to, and the bottom tells me what root is being taken. So I see that I'm being raised to the third power, so the top of my fraction would be 3, and I'm taking the fourth root. So the denominator at the bottom of the fraction would be 4. So we can rewrite this expression as x to the power of 3/4. I'm taking the fourth root of x and raising it to the third power. So we have radical form and exponential form with a rational exponent. All right, so when we're dealing with actual numbers, there's actual operation that needs to be performed. So let's say that I have 16, and 16 raised to the 3/2 power. And I want to simplify this. I could write this back into radical form and see what that means, which is a perfectly good way to go about it, or we can just go through and take it step by step. So the number on top, the 3, tells me I'm going to raise 16 to the third power, so 16 times 16 times 16. And the denominator, the 2, tells me to take the square root. or the second root, which is the square root. Again, the order doesn't matter. For me, I like to take the root first because it makes my number smaller, and then when I raise it to a power, I'm not multiplying such large numbers. So I'm going to take the square root of 16 first, and the square root of 16 is 4 because 4 times 4 gives me 16. So handling the 2 in the denominator first, again, that means I'm going to take the square root. So the square root of my base, the square root of 16, is 4. So what that leaves me with is 4 still raised to the third power. Now 4 to the third power means to multiply 4 times itself 3 times. So 4 times 4 is 16, and 16 times 4 gives me 64. So 16 to the 3/2 power simplifies to 64. Now we can turn up the heat a little bit. Let's say that I have 9 over 25. Let's just do raised to the negative 1/2 power. So now I have a fraction raised to a power. So our power rule comes into play here. I have 2 different things. They're being divided inside of the parentheses raised to a power. So these all technically have a power. So this negative 1/2 is going to go to both the top and the bottom. So what does the 1/2 rational exponent mean? So the 1 up top means I'm raising to the first power. So anything raised to the first power is just itself. So 9 to the first power is 9, 25 to the first power is 25. The 2 in the denominator is telling me to take the square root. So I know I have to take the square root of the top and the square root of the bottom. And the negative exponent, if you recall, tells me that those values are in the wrong spot. So I'm going to end up flipping my fraction. So again, I'm going to start by doing the root. So this is the square root. The square root of 9 we know is 3. And the square root of 25 we know is 5. So taking into account the square in the denominator, the square root of 9 is 3. The square root of 25 is 5. And now I took care of the 2, but that still leaves me with a negative 1. Anything raised to the first power gives me the same value back out. So 3 to the first power is just 3, 5 to the first power is just 5, but I have this negative here. So if we distributed the negative power, we would see that we have 3 to the negative 1 over 5 to the negative 1, which indicates that both of those values are in the wrong position. So they need to swap. The 5 needs to go up top and the 3 needs to go into the bottom. So we end up with 5/3. So 9/25 raised to the negative 1/2 power simplifies to 5/3.